Okay, so let's go take a look at our slide from the other day. So I introduced the topic of searching. A common task when working with arrays is to search an array for a particular element. And like I described the other day, there's two ways we're going to be searching. A linear or sequential search examines each element of the array in turn until the desired element is found. And if it's not found, we'll return a -1 or something, usually a negative number. A binary search is more efficient than a linear search, but it can only be performed on an ordered list. And that's where we ended class the other day. A binary search examines the middle element and moves left if the desired element is less than the middle and right if the desired element is greater. This process repeats until the desired element is found. So what I want to do is, you have the searches code in front of you. So what I'm going to do is I'm going to turn my camera on. Did anybody write that array down from the other day by any chance? The one I wrote on the board? Did anybody write that down? I'm just going to use, I would like to use that same example. Thank you. I'll give this right back to you. Oops, this doesn't work. All my cool pens are missing. Okay, so the other day we had this integer array 1, 2, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Uh-oh. 8, that's right. So we had these values. And I just called this array X. All right, so the other day we referred to the code, so now we can actually look at it. And what does anybody remember what number we were searching for? Was it 7? Let's pretend that we're looking for 7. And let's pull up our searches code now. So one thing to notice about this code, I'm you as a student. What's one observation you can make right away about this method, linear search? Raise your hand. Tell me something that's a little, David? It's static. And the name of our class is searches. So in order to access linear search, we're going to have to say searches.linear search. What else do you notice? Okay, so it's passing an integer array. And then, Alex, did you have anything else you want? Okay, so let's start pretending. Maybe we should jump over to JGrasp and in a second. Okay, so we have a linear search method that's been written for us. It's accepting an integer array. Well, we have an integer array, correct? Then we also have something called a key. Let's read the comments above. Searches the array of integers for the specified element using a linear search. The index where the element was found is returned, or -1 if the element is not found. So let's pretend that we're sending this X array and that we're looking for 7. So let's come here. How does this work? We have a for loop. So index equals 0, index less than numbers, dot length, index plus plus. If key, so we would be sending 7 because that's the value we're looking for. If 7 is equal to what we find in the array at that index value, starting at 0, so numbers of 0, but really numbers is an alias for X. Numbers is an alias for X. So we would be saying, is 7 equal to 9? It's not, correct? Now, if you recall back from last year, is that how that works? Okay, I'm not going to say that. Never mind. All right, so we didn't find it. so we increment index to 1, and now we're checking 7 against numbers of 1, which is a 1. It's still not equal, so we're going to keep processing this for loop until we eventually get to an index of 5. So 7 is equal to 7. I will return the index, and what I return is 5. I don't return 7, I return 5 because the index where the element was found is returned. Does that make sense? I think we should try it. So if you're sitting at your computer, I'm going to ask that you please start JGrasp. You're going to need to do a couple things. You need to go to the source code folder, and you need to make sure that you have searches saved into the directory you're going to make your little driver program. So I have searches here. I don't know where you guys are saving everything, so I'm just going to do a file save as. I'm just going to put it on my desktop for now, and then I'll move it to where I need to move it later. Oh, wrong one. Searches. You guys should put it in your H drive, probably, right? Okay, desktop. All right, make sure it compiles, and it will. So now we're going to write a driver program. So I'm going to call this phase 3. Oh, how about chapter 6, phase 3? Public, static, can't spell, void main, string, args. Okay, so the first thing we need to do is we need to put in that integer array. So int bracket x equals, let's do an initializer list, 9, 1, 6, 4, 3, 7, 4, 2, 5. I think that's right. I'm going to go ahead and do a file save as and compile and make sure I didn't do anything stupid. So far, so good. Okay, so as you recall, when we look at our linear search here, this is going to return an integer. So I need to, in my program, be prepared for that integer to get thrown back at me. Okay, so I want to store it in a variable. So int, I'm going to call it where find 7. That's my variable name. Where am I going to find 7? So now in order to call the linear search, I have to use the name of the class because that's a static method. I'm going to say searches dot linear search. I send it a reference to my integer array, which is what? Just x. And then I'm looking for 7. Does everybody get that? Yep. Okay, perfect. And then let's just put an SOP in there. I really wish SOP was a command, you know. Really do. 7 was found at index location concatenated with where find 7. Let's see if that compiles. Oops, sorry. Okay, so we got the answer we were looking for. Does everybody agree? All right, so let's do this again. Let's copy this where find 7 line, and this time, let's search for 8. Do we have 8 in our array? No. So according to the method, what should get returned? -1. So let's copy the SOP and paste it.